In this video, I will talk about ergodic Markov chains. First, I will introduce some new concepts about Markov chains. In a Markov chain, a path from state I to state j is a sequence of transitions that begins in I and ends in j, such that each transition in the sequence has a positive probability. A state j is reachable from state I if there is a path leading from I to j. Two states I and j can communicate if j is reachable from I and I is reachable from j. A set of states S in a Markov chain is a closed set if no state outside of S is reachable from any state in S. Let's see an example. This Markov chain has 5 states. This is the state transition matrix. In this example, state 3 is reachable from state 1 via the path 1, 2, 3. But state 5 is not reachable from state 1. There's no path from 1 to 5. States 1 and 2 communicate. We can go from 1 to 2 and from 2 to 1. Set S1, which contains 3 states, 1, 2, and 3, is a closed set. Set S2, which contains 2 states, 4 and 5, is also a closed set. A state I is an absorbing state if Pii is equal to 1. That means the probability of the transition from I to itself is 100%. If we enter an absorbing state, we will never leave the state. An absorbing state is also a closed set containing only one state. Here is an example. In this Markov chain, both the first state and the last state are absorbing states. Other states are not absorbing states. A state I is the transient state if there exists a state j that is reachable from I, but state I is not reachable from state j. It means once you leave a transient state, it is possible you will never return to this state. If a state is not transient, then it is called a recurrent state. In this Markov chain, there are 3 transient states, 2, 3, and 4. For example, we can go from 3 to 2, and then 2 to 1. Then we get trapped in state 1 and will never come back to state 3 again. The other 2 states, 1 and 5, are not transient, so they are recurrent states. In this Markov chain, the 3 states on the left are all transient states. If we go from one of these 3 states to one of the states on the right, we will never come back to the left. The 3 states on the right are all recurrent states. A state I is periodic with period k, where k is greater than 1. If k is the smallest number such that all paths leading from state I back to state I have the length that is a multiple of k. Absorbing states are aperiodic. If we can return to a recurrent state at irregular times, it is aperiodic. In this example, we have 3 states. They are all recurrent states. There is no absorbing state. All states are periodic with a period of 3. For example, starting from state 1, we need 3, 6, or 9 steps to come back to state 1. The multiple is 3. Now let's take a look at this example. We know that the absorbing states 1 and 5 are not periodic. The transient states 2, 3, and 4 are not periodic because we may not come back to these states again. Similarly, in this example, the transient states 1, 2, and 3 are not periodic. But the recurrent states 4, 5, and 6 are periodic and the period is 2. If we start from any of these states, we can return to the state at time 2, 4, 6, and so on. If those states in a Markov chain are recurrent, aperiodic, and communicate with each other, then this Markov chain is ergodic. Ergodic Markov chains have some special properties, which will be introduced in another video. Let's see some examples. Is this Markov chain ergodic? No, because it has some transient states, 2, 3, and 4, and state 1 cannot communicate with state 5. Is this Markov chain ergodic? No, because it has some transient states 1, 2, and 3, and some states cannot communicate with each other. For example, we can go from 1 to 2, but not from 2 to 1. Is this Markov chain represented by states 1, 2, and 3 ergodic? Yes, none of the states is transient. There's no period, and every state can communicate with other states. What about the Markov chain represented by states 4 and 5? Yes, it is ergodic for the same reasons. What about the Markov chain represented by states 1 through 5? No, it is not ergodic because states 1 to 3 cannot communicate with states 4 and 5. Okay, that is about ergodic Markov chains. Thanks for watching.